Hundreds of spectacular and very dangerous fires are keeping firefighters stretched to the limit out west. The unprecedented outbreak affects several states and has forced the
have been called out to help. More than 12,000 firefighters spread through Idaho, Oregon, and northern California.
67,000 acres in Northern California.
Contain the rash of fires. The Forest Service is also asking the Army for help.
They want us to, they said we can stay here as long as possible. When our lives are in danger, they want us out of here or they will carry us out.
More than 900 separate fires raged through the night in California with no relief in sight.
It's just real scary to think that our friends and neighbors are going to lose their home and possibly us.
Their property to fight the flames. Crews all over the threatened areas have gone from house to house and saved all but a very few homes.
In an average year, forest fires destroyed over 1 million acres of land. What took centuries to build, nature wiped out in a flash of lightning. Some of this forest was parkland that may never be replaced. Other land destroyed supported families who lost all of their possessions, or worse, their lives. These forests were also the life force for many animals. They too lost more than just their homes. What was once a thriving, balanced ecosystem was laid to waste, part of the endless cycle of replacing the old with the new. Unfortunately, there are times when these fires are too great for nature to effectively deal with. Often they threaten destruction of precious areas, be it home for humankind or special forest lands too important to lose. It is these times when technology and nature must battle, and technology must win. In a relatively short period of time during 1987, fires destroyed over 1,200,000 acres of land. Some of the worst of these fires occurred in western states like Idaho, Nevada, Oregon, and in California. Most of these fires are started by severe lightning storms within these regions. The fires are only encouraged by the West's common dry spells. The combined ferocity of the storms and extreme dry land produced some of the most difficult fires to control. Successful suppression of these and other fires often depends on timely and accurate weather forecasts. To assist the firefighting effort, the National Weather Service provides on-site meteorologists to help predict how the weather is going to affect the fight. Together, the firefighters and the meteorologist create a dynamic team to achieve the common goal, control and elimination of the fire. In order to provide this service, the on-site fire weather meteorologist depends heavily upon information obtained through instrumentation and communication equipment that's been packaged into a compact system. This system is simple to transport, assemble, and operate, but familiarity with the system is essential. The Air Transportable Mobile Unit, or ATMU as it's called, is the system. This program is an overview to the ATMU's transport, assembly, and operation. It's not intended as the single source of information on the ATMU. Only periodic hands-on experience will adequately prepare the on-site meteorologist for using the ATMU at an incident. The ATMU consists of 3 primary sections, packaged within 7 transport modules. The first section is the Equatorial National Facsimile, or NAFAX. This provides the meteorologist with printed weather charts and other data. The second part of the ATMU is the Climatronics Weather Station. This provides data on local weather variables, such as wind direction and velocity, dew point and temperature. And finally, the ATMU contains a pilot balloon, or pieball, observation system. This way, the meteorologist can track air currents of the upper atmosphere, critical to predicting the direction the fire might advance. Before the ATMU and meteorologist can arrive at a wildfire site, certain procedures must be followed. First, contact should have been made with potential users of the on-site forecast service. Users should be well informed of dispatch procedures for both the ATMU and the on-site meteorologist. This is done either through personal contact or through the Fire Weather Operating Plan. In addition, all transportation and logistical needs should be known in advance of the mobilization. Requests for ATMUs and the supporting National Weather Service certified meteorologist will come to a centralized dispatch location where the status of each resource is known within given geographical areas. The dispatcher will call the appropriate certified meteorologist to provide the on-site forecast service. When the availability of the meteorologist has been verified, the dispatcher will call the appropriate ATMU holding facility or cache to request an ATMU. If either the meteorologist or the ATMU is unavailable within the dispatcher's area of responsibility, the request will be forwarded to the Boise Interagency Fire Center, also known as BIFC. Here, the nationwide status of both the ATMUs and certified meteorologists is maintained. Assignments of ATMUs across the regional boundaries are made by the BIFC staff. Assignments of certified meteorologists across district and regional boundaries are made by the National Weather Service staff meteorologist to BIFC. When a certified meteorologist has been identified and requested, the local National Weather Service supervisor must make the final decision on his or her availability. Once that determination has been made, the meteorologist needs to obtain a great deal of information prior to leaving for the fire. A spot forecast may be requested to guide the fire suppression organization until the meteorologist arrives at the fire. If so, obtain the information necessary to complete Weather Service Form D1, the Fire Weather Special Forecast Request Form. You'll also need information concerning the location of the fire and the name of the fire behavior analyst or other person to whom you should report. This is a good time to reiterate any logistical needs, such as shelter and electrical power. Also, find out if a telephone line will be available. The meteorologist needs to make arrangements with the dispatcher for his or her transportation to the fire site. Also, the meteorologist should find out how the ATMU is being shipped. Most importantly, the resource order number should be known along with a request number. The meteorologist should receive a copy of these documents. They may be helpful in tracking the shipment of the ATMU and for their release from the fire. Prior to departure, the meteorologist fills out a travel order with the proper task numbers. Use the federal reimbursable task number unless other local or regional agreements are provided. Finally, arrangements for access to an office database should be made available for dial-in data through a portable computer terminal. The ATMU will be dispatched from a local cache site if possible. Transportation methods are determined by the Incident Management Agency in coordination with the dispatch agency and cache site. The meteorologist should find out the method of shipment so that he or she can help expedite delivery of the ATMU if any problems should develop. In some cases, the meteorologist may travel with the ATMU. If the unit must be shipped by commercial air, the cache should be instructed to repack module number 5, the climatronics recorder, in order to properly protect it during shipment. Upon arrival at the incident, the meteorologist should check in with the Fire Behavior Analyst, or FBA, and the Plans section. If available, the FBA should be relied on as the medium for obtaining the logistical and service support that the meteorologist may need from the fire suppression organization. A location should be scouted to set up the ATMU equipment, and the briefing schedule should be obtained to determine when the meteorologist's presence will be required. If at all possible, arrangements should be made to tour the fire area to get an overall view of how the fire has behaved and to look over the topography that will be influencing the weather and the fire. Also, arrangements should be made for the location of the climatronics weather station, along with supplemental weather observation within the fire area. Observations can be either from existing fire danger network stations, portable remote automatic weather stations, or by manual observations taken by fire personnel with belt weather kits. Upon arrival at the operations site, prepare all the modules for assembly. Within module number 1, all the equipment necessary for the reception of NAFAX charts, except the marine facsimile, can be found. In the top section in the base of the module is the satellite antenna dish. In the lid of the module attached by Velcro fasteners is the mounting frame for the dish. In the lower section of the base is the antenna to controller cable, the controller, and the waveguide and feed horn. This section also houses the Digital Image Transmission System, or DITS, along with a low noise converter, or LNC. Also, an inclinometer is included to assist in setting the proper elevation angle of the antenna dish, along with various hardware and tools. In module number 2, The top layer contains the cables for the Climatronics weather station, a flashlight, helium tank regulator, and hoses for the pieballs, optional feet for the Climatronics mast, and a first aid kit. The calculator for pieballs is also stored in this layer. The second layer contains the marine facsimile, while the third layer stores the rolls of paper for the facsimile and other miscellaneous tools. Also note that the theodolite for pieballs extends through both the second and third layers. Extension cords can be found within the first layer of the third module. The second layer also holds 2 boxes containing miscellaneous office supplies, a lantern, an extra paper roll for the Climatronics recorder, the Climatronics dew point assembly, 2 file folders with expendable supplies, and 2 belt weather kits. The Texas Instruments Model 707 portable computer terminal is mounted in the bottom layer, along with paper and clipboards. Module number 4 contains the temperature and wind sensors for the Climatronics weather station. This includes the temperature probe, wind speed and direction arm, anemometer cups, wind vane, and power cable. Module number 5 is the Climatronics recorder, which records the wind speed and direction, temperature, and dew point upon pressure-sensitive paper. Cable connectors are on the side of the case. Module number 6 is a canvas bag containing the mast for the Climatronics weather station. And finally, module number 7 is also a canvas bag containing the tripod for mounting the theodolite. Start the assembly process of the ATMU by setting up the equatorial NAFAX system. First, unpack all items from the lid of Module 1. Then, remove the satellite dish and set up the mounting frame. Attach the dish to the frame and elevation strut and raise the dish to the approximate angle of elevation. Tighten the nuts and bolts just enough to hold the antenna in place. Now, the low noise converter, or LNC, and waveguide are unpacked from the bottom of module number 1. The retaining ring from the LNC is removed, and the waveguide is attached using 6 Phillips head screws. Care should be taken when attaching the screws. They can easily be lost on the ground. The feed horn is removed from the waveguide. The waveguide is then inserted through the rear of the dish. The cable jack for the LNC is kept pointed downward. The retaining ring is replaced and the assembly is fastened by placing 4 nuts over the 4 protruding bolts. These nuts do not need to be secure at this point. Finally, the feed horn is reattached to the waveguide. Using the compass from a belt weather kit from module number 3, the base of the antenna is rotated in the proper direction. The directional information for alignment of the antenna to Galaxy 3 is provided in Appendix 2 of the ATMU operating manual. Place the inclinometer upon the waveguide so the needle moves freely. Loosen the elevation strut. Then carefully adjust the angle of elevation as determined by Appendix 2. After elevation is set, retighten the mounting bolts. The antenna then must be polarized. Once again, Appendix 2 provides the needed data for the setup angles required in various parts of the country. The 4 nuts and retaining ring holding the LNC waveguide assembly are removed. While facing the dish, the assembly is rotated to the correct polarization, rounded off to the nearest 10 degrees, and is rotated 1 hole for every 10 degrees of polarization. The assembly is rotated clockwise for negative angles and counterclockwise for positive angles. Then the retaining ring and 4 nuts are replaced and tightened securely. The 50-foot coaxial cable is connected from the bottom of the LNC to the left rear of the controller. Then the RS-232 cable is attached from port number 1 to the rear of the DITS receiver. Care should be taken that the 25-pin connectors mate properly and that they're not damaged. A telephone plug cable is connected between the marine facsimile recorder to line jack number 1 on the DITS receiver. Then the red and green signal wires are connected to the right rear of the facsimile. Only the top and bottom terminals are used. The middle is left unused, and either wire may go to either terminal. Then the power cord is connected to the DITS receiver and plugged into a 120-volt AC source. The cover on the marine facsimile is opened, and the stylus belt is inspected along with the 2 styluses, which should be clean. The belt is pulled to the left in its track to inspect its entire length. A length of paper is pulled from a roll of facsimile paper and inserted into the cassette of the machine. If there's any problem with removing the paper, replace the roll. The machine will not be able to advance any paper that cannot be pulled by hand. The cover is closed by pressing the red release button on the right hand of the cover. Activation instructions are provided within the Equatorial User's Manual and ATMU Operating Manual. All information on the operation of the NAFAC system is explained within these manuals. After the NAFAC system is operating, the Climatronics weather station is assembled. The mast for the station is removed from module number 6 and is set up on a hard surface. Should there be only loose or damp soil, module number 2 contains large flat plates that attach to the bottoms of the tripod legs to stabilize the mast. The mast is then raised. The temperature assembly is removed from module number 4 and is mounted on the center pole. A 5/32 Allen wrench is used to tighten the assembly. Then 3 screws are carefully removed from the top of the sensor. A sun shield is mounted and the screws are reattached and tightened. The wind crossbar is removed from the module and mounted on the center pole. Then the 3-cup anemometer is set on the wind speed hub and tightened with a small Allen wrench. The wind vane is placed with the flat portion of its hub parallel to the flat portion of the wind direction mast and is tightened with an Allen wrench. The wind vane should be oriented to the east, the wind speed sensor to the west, and the temperature sensor to the south. Then the crossbar screw is tightened. The wind cable from module number 2 is connected to the assembly, and then the wind crossbar is raised to the top of the mast and locked. The dew point assembly is removed from module number 3 and connected to the arm supporting the temperature sensor by 2 U-bolts. The U-bolts are placed through the mounting plate with the round part flush with the arm and the dew point sensor pointing downward. The dew point shields are removed by loosening the mounting screws with a small Phillips screwdriver. These screws should not be fully removed. They might be lost in the grass. A protective tube is removed to expose the wick. Do not touch this wick. It is very sensitive. If the dew point sensor was stored independent of the assembly, it would be plugged in before removing the protective tube. The metal dew point shields are replaced and the screws tightened. Then attach the temperature and dew point cables and make sure that all the assemblies are properly oriented and at the proper height. All the cables from the weather station are connected to the recorder. The cover on the recorder is removed to provide access to the chart roll by loosening the knob in the upper left of the chart housing. The ATMU operating manual provides additional instructions to replace the chart paper and to perform any other maintenance. Screws to access the battery compartment are loosened and the batteries are connected in series. Figure 9 of the ATMU operating manual provides correct connection information. There are 2 sets of terminals to fit 2 different kinds of battery posts, so be sure that the unused terminals are protected from grounding out the system. Then the power switch is set to the internal or INT setting and power is supplied. It takes from 15 to 30 minutes for the dew point sensor to stabilize before accurate data can be obtained. The third system to set up is the pilot balloon or pieball observation equipment. Module number 7 holds the tripod, which should be set up in an open, level location. The legs are spread and set to roughly level it. The top ring from the tripod is removed to mount the theodolite, which is packed in module number 2. Before the theodolite is removed from its box, note how it's been stored. It can only be replaced in the same position it was stored in. Then the theodolite is carefully removed from its box and the storage base is unscrewed, then placed within the box. Then the theodolite is screwed onto the top of the tripod. After releasing the azimuth tangent screw, rotate the theodolite until the bubble levels are parallel to the pair of adjusting knobs. Then the tangent screw is again engaged. To center the bubbles, turn a pair of opposing adjustment knobs simultaneously in opposite directions, always keeping tension on them. Repeat this process for the other bubble. After completion, rotate the theodolite 90 degrees and repeat the leveling process again. In order to orient the theodolite to true north, the tangent screw is released. The theodolite is rotated until 360 degrees is read on the base, and then the tangent screw is reset. Then a turnkey underneath the base is loosened, and the theodolite is swiveled until the scope is pointing north, parallel to the compass needle. The turnkey is then retightened. A balloon is removed from module number 3 and is attached to the nozzle. The regulator is connected to a helium tank, and the valve is turned, allowing the balloon to fill until the balloon and nozzle just lift and stabilize. The balloon is then tied off and removed from the nozzle. With assistance from one of the incident personnel, the balloon is released and tracked. The elevation and azimuth angles are recorded every minute of the balloon's ascent. A programmable calculator such as the Casio FX720P may then be used to calculate the wind speed and direction for each minute. Again, the ATMU operating manual contains all required information to perform these operations. Throughout the mobilization, the meteorologist should maintain a log to document all activity at the fire. The briefing should be used as a two-way street, a time to give needed information tailored to the current attack strategy, and to also find out from people on the fire line how the weather has varied across the area. When the on-site forecast services are no longer needed and the meteorologist is released by the incident commander, he or she should follow the local agency checkout procedures. Once the incident has been controlled and the meteorologist and ATMU is released, the equipment should be repacked in each associated module. At this time, the meteorologist should note the deficiencies and place a list of supplies and repairs needed inside module number 1. The responsible office, listed in Appendix 4 of the ATMU operating manual, should be contacted and a decision made on whether to ship the ATMU to the maintenance and restocking office before it's placed in the cache. Regardless of whether the ATMU is returned directly to the cache or diverted to the maintenance and restocking office, any deficiencies should be corrected. Necessary maintenance should be arranged according to instructions in Appendix 1 of the ATMU operating manual. Restocking of expendable supplies should be done by the maintenance and restocking office, either at that office or at the cache. Following the return from an incident, it's important for the meteorologist to document all participation in order to properly account for financial obligations and also to expose any special problems that may have been encountered, so recommendations may be passed on for the improvement of the program. All copies of travel vouchers should be completed and forwarded according to regional policy so that charges may be directed to the proper agency. In addition, reports of reimbursable expenses should be filled out and forwarded to regional headquarters. These reports should detail the individual expenses incurred on an incident. A copy of this document is also forwarded to the responsible user agency so that costs may be recovered from the proper agency's funds. Further details of the forecast and logistical problems encountered at the fire should be listed on Weather Service Form D21, the Fire Weather Mobile Unit Operation Report. This should also be forwarded to regional headquarters and a copy kept on station for future reference. All forecasts made for the incident should be saved in accordance with current National Weather Service policy. It's a good idea to make a file of all documents associated with the incident, including forecasts, report of reimbursable expenses, Weather Service Form D21, and all data received in the field. This may be used for forecast improvement studies or to provide information regarding the performance of the ATMU or meteorologist in the field. At all times throughout the mobilization, the meteorologist should use good judgment before releasing any information. Many people and much forest land relies on accurate predictions. The meteorologist is just as important a part to the firefighting team as any personnel on the scene. Accuracy and responsibility must be maintained at all times. The meteorologist should be prepared to go on site at any time, anywhere, and be comfortable with operating within the situation. Remember, the more hands-on experience one has with the ATMU, the more efficiently the ATMU can be utilized. Fires don't wait for convenient moments to break out.